In this lecture, we're going to show you how to reduce that warming and bend that curve by as much as 6/10 of a degree Celsius just in the next 30 years, so that we'll be cutting down the projected warming by almost 50% from now to 2050. This falls basically under solution number 9 of our 10 solution set, where we are asking to immediately make maximum use of available technologies to cut black carbon emissions by 90%, methane emissions by 50%, and completely phase out HFCs, that's hydrofluorocarbons. These are called the short-lived climate pollutants, and their basic advantage is that their lifetime, so just a week to about 15 years for HFC. So what does that mean? Take black carbon, its lifetime is a week. If we put filters in every vehicle on the planet to take out the black carbon, they will be gone within a month, and their climate forcing would be gone within a month. So that is why they're such a low-hanging fruit. And the second advantage is we have off-the-shelf technologies and policies to make drastic reductions. And given their short lifetimes, their effect on climate would show up in almost less than 10 years. So some of you might be hearing about this for the first time. So how long have we known about the short-lived climate pollutants? Since 1975, when the chlorofluorocarbon greenhouse effect was discovered. Today, my co-lecturer is Professor Derwood Zalke, a pioneering environmental lawyer. He's going to talk to you about the Montreal Protocol, how that was used to get rid of these chlorofluorocarbons, and how they're being amended to phase out HFCs. These short-lived climate pollutants are also known as superpollutants because per ton they are significantly more potent than that of carbon dioxide. Methane is about 25 times more potent, black carbon 500 to 2,000 times more potent, and HFCs 1,000 to 4,000 times more potent. So in today's lecture, we have 3 learning objectives. The first one is, how do we bend the black carbon curve? Second, how do we bend the methane ozone curve? Third, how are we going to use the Montreal Protocol, amend it to phase out HFCs? So the lecture is broken into 5 modules. I'm going to talk to you about modules 1 to 3, and Professor Zalke will talk to you about modules 4 and 5. So this is the module 1. What I'm showing you here, just focus on the right-hand side first. These are model projections, okay, of the past, recreating the past and projecting the future. And the pink one is the observed warming, okay? If you focus on the top one, we just go straight on up, that is business as usual, okay? And what that tells you is that there is a 50% probability the warming can exceed catastrophic 4 degrees even before this century, okay? That's exactly why courses like these, reaching out to young people to solve the problem, is extremely critical, okay? So let's look at the dash curve, which is just making the planet carbon neutral. What we did in this is started bending the CO2 lever beginning today and finish that bending, go to carbon neutrality by 2050 to 60. And you see that the warming takes a long time to respond. It does bend the curve, doesn't happen till 2050. Simply because of the long lifetime of CO2. It's like a super tanker. You can't just turn it overnight, okay? Next, focus on the short-lived climate pollutants. We followed solution number 9 very closely, started bending that curve, beginning now and finished whatever the target was by 2030, 35, and you see how the curve starts bending immediately, okay? But that also doesn't prevent exceeding 2-degree warming. It's when you combine the two, both the levers, okay? You can keep the warming under 2, but what the short-lived climate pollutants, what it does for you is that it pushes that 2-degree warming somewhere between 20 to 30 years further down. And who benefits from that? So let me introduce you the color scheme. The green is subjectively drawn below 1.5, so-called safe zone. We don't know that for sure. The yellow is where you could transition into dangerous climate change. But beyond 2 degrees, when you go to the red zone, almost all the climate scientists and the environmental scientists, policymakers I know, they have concluded it's dangerous territory. Okay, we talked about that in our lecture too. While everyone would benefit, for the poor, it's a question of life and death. So I want to take you to homes of 3 women in villages, and let's see what it would mean. Then you'll realize what this such a large climate change would impact the poor. Okay, so we're going to follow 3 homes, 3 women, right? I am house guest of these women. So in the first house I had breakfast, the second house was lunch, and the third house was dinner. Okay. So the daughter and her mother were cooking breakfast for me and my wife. We were the house guests there. And the smoke. It's the most delicious breakfast I had. And look at the smoke. There are 600 million people along the so-called Indo-Gangetic, North India, cooking. The smoke spreads all the way across and reaches Himalayas, and the black carbon was shown to melt the glaciers. Okay? Now let's go to lunch. This is 1:30 in the morning, afternoon, bright as sun. She's just worked in the farm and then come back, take a rest, and then cook the dinner. So she's lighting the kerosene lamp, a deadly source for health and her health. And why am I showing this? The daughter, around 2 in the afternoon, walks to this area where they clear the trees, 2 kilometers away. Imagine walking. And she will return back with a load full of firewood. And she asked me not to take a picture of that. She said, it's just, I don't look good doing this. So I didn't take her picture. And then the mother cooks by 4, 5, comes 6 o'clock in the evening. Let's see what she does. This is now the mother. She's collecting water. Watch how she collects that water. She can't afford to waste a drop. Okay? Look at that frog. See, she was taking the water to cook my breakfast next day. I was thinking about the frog, and she saw me terrified, and she told me, sir, don't worry. I make sure I remove the frog before I cook for you. Now watch her. She can't afford to waste a drop of water because that's for cooking, her kids bathing for a full day. And I didn't think she was going to put the second pot on her head. Now think about what droughts would do to her. Not a drop. Even today, when I shave and let the water run or stay in the shower too long, I think about that scene. And you immediately go to shut the water off. So we need to experience what poor beings, okay? Now she's walking back. The thing is, she asked me not to take a picture of that. She has no shoes or sandals. She had to carry that water 2 kilometers. While that's happening, by the time we had lived in the village for a week, so we were really tired, so we were leaving. So I saw 20 kilometers from that village, this amazingly huge lake. They can't access water from that because that's for the big cities, okay? And then, just close to that was the place I stayed. I'm going to talk to you about 2 worlds, the top 1 billion and bottom 3. That's what we live side by side. Of course, all for myself, I can say is I enjoyed that resort, but I just couldn't bring myself to take a dip in the swimming pool. I was thinking about the well water she was taking. So now as we had stayed in villages for 2 weeks, we were tired, so we were going back to Mumbai. This is about 3 hours from the big mega city, Mumbai. Driving through rows and rows and rows of slums. Think about what they will do with 6 feet of sea level rise, okay? And again, I want to show you the 2 worlds living side by side. Look at that tall building. 1 person is living with his family there. That's the view from my 4-star hotel in Mumbai. Guess what I'm doing? I'm having a glass of beer. And the memory of these women had faded away already. So that's what happens. It's easy to forget and sit here, plan for 2-degree warming, 3-degree warming, and talk about adaptation. They would be wiped out. Okay, so let's find out how many such poor people are there. 3 billion. We have left behind 40% of the planet. They have no access to fossil fuel or they cannot afford it. And 3 million of them die every year. More women and children because her oldest child is about, youngest child is 6 years old. Otherwise, they hold the child in their hip when they're cooking. And their contribution to CO2 emissions is 5%. That's me. I contribute 50% of the CO2 pollution, the top 1 billion, okay? That's all the adults. How about you guys? You are the middle 3 billion, okay? You're living in low-lying areas, 1st and 2nd floor apartments, of course, mixed with people living in poverty, who the Pope Francis calls socially excluded. So that we have to think about at least these 3 categories when we talk about adaptation, what it means 2 degrees. So I took this moral and ethical issue to Pope Francis a year before he wrote the encyclical. And then I took our Governor Jerry Brown to the Vatican. And we are forming an alliance between science and religion and policy, okay? Because it's become a moral ethical issue. So hopefully, through the religions, we can reach out to the people. And the second thing I want to mention is that Durwood Zalke and I, we started teaming up with here in beginning 2008. We talked to the UN agencies, and we did reports, and they formed a Climate and Clean Air Coalition. The person mainly responsible for forming this coalition is Hillary Clinton. So let's talk about the black carbon part. What are the major sources of black carbon? Diesel trucks. And below what you see is brick kilns, but there are many industrial sources puts that black smoke. Forest fires are burning vegetation. In California, we used to burn our agriculture waste until about 5-6 years ago, and then we saw that cooking. That's the 2nd largest source of black carbon, cooking with firewood and dung. And the first is diesel. So why we need to target black carbon? Forget about the climate effect. Health effects alone, it leads to over 3 million deaths per year. It's the 2nd to 3rd largest global warming agent. when the black carbon deposits on sea ice, our glaciers here are snowpacks, it melts them directly because it makes the bright surface dark. And it cuts down sunlight going into the ocean and decreases rainfall. All of them have been documented with data. So how do we get rid of them? In the transportation sector, the diesel sector, amazingly, the solution is there. That diesel particulate filter, okay, it's completely self-regenerated. The black carbon deposits on the car filter in the tailpipe. Every couple of weeks, so when the thing is piled up too much, the car turns on a heater, burns the thing off. So it's completely automated. You can't drive a car in California and some European cities without these filters. They get rid of as much as 99%. Am I trusting what the industry says? No. We made measurements in California. California started these laws in 1990, and you can see the data around. The air we breathe has become a lot cleaner. We've gotten rid of 50%, 50 to 70% of black carbon. So now let's go back to this woman's kitchen we talked about, okay? I want to show you a personal example to convince you why individually each of you can have a huge impact on reducing short-lived climate pollution, because this is a classical bottom-up effort, okay? Again, a minute of video.
In October 2009, after more than 2 years of gathering support and financing, Ramanathan and collaborators from the Energy and Resources Institute in India distributed efficient, low-emission cookers and solar-powered lanterns to households in the village of Kairatpur, located south of the Indian city of Lucknow. Most village residents live below the poverty line, gathering sticks, wood, and cow dung to make fires in homemade stoves.
So let's just talk about the cook stove. Why did we distribute that stove? So it's called forced draft biomass stove. It still burns firewood. They can't afford to buy fuel. It's easy to put gas stoves in there, but they just can't afford to buy it. So the forced draft, there's a small fan which sends a steady supply of oxygen, so it cuts off almost all of the smoke, and it also cuts the fuel combustion. So we make a claim at $12 a ton, the woman can recover the cost. She can't afford to buy a $70 stove. That's about 35 days of her wage. How many of you here would buy a stove which costs a month of your salary? That's it. No one. So how do we do that? It turns out that stove cuts 50% of CO2 emissions, 80% of BC emissions, and as a result recovers as much as 5 tons of CO2. So if she could get $12 per ton, remember, she has become a climate warrior, setting an example for the rest of us. So if we can reward her for that, so the issue is, how do you reward it? So this is where it's nice to have children. I forced 2 of my daughters to join me in this work. One of them was a wireless technologist. The other one is a social welfare. That's what her interest was. So they designed a small sensor, attached it to the stove, and it sends data back to her server in Los Angeles, and they monitor how long she's using it. Then we convert that to carbon credit. That's how we came that estimate. So they have now tried it over 1,000 homes. Finally, there is a mechanism to reward protecting climate and giving that reward not to corporations, but to individuals, okay? So just one example, and I'm fairly convinced the SLCPs are going to be cut down by bottom-up efforts, at least black carbon and methane. So some of the questions I want to leave you with is severe droughts and floods and sea level rise of the sort we expect with greater than 2 degrees. For them, it's not a question of adaptation, it's a question of existential threat, okay? So what sort of protection and governance are available to protect them? I know of no agencies or UN thinking about this. A lot of lip service done, but nothing concrete. How are we going to deal with this 3 billion? Okay. And so can religions and civil societies play a role? I hope all of these you would factor when you're talking about living laboratories. So let's talk about the methane mitigation. Methane impacts climate 4 different ways. It's probably the most insidious greenhouse gas. It has a direct greenhouse effect, which is 25 times more potent than CO2. Then methane, when it's oxidized, produces carbon dioxide, and we know that's a greenhouse gas. In that oxidation process, methane produces ozone, which is a major greenhouse gas in the lower atmosphere. Doesn't stop there. It goes up to the stratosphere, oxidizes to water vapor, one of the most potent greenhouse gases. Okay? So together, ton of methane can have same effect as 25 to 90 tons of CO2. The other deadly thing about methane, the ozone formed by methane, is the dominant destroyer of crops. Over 110 million tons of crops are destroyed every year. North America, where we live here, loses 39% of its crops to ozone. Asia, 37%, and so on. So there are many reasons to get rid of methane. So what are the methane sources? The top left, you see coal mines, production of oil, the methane leaks, and then the methane leaks from pipes. That's the right-hand top corner. Go back to the bottom left, rice paddies. Anytime you have organic stuff without exposure to oxygen, it produces methane. So in the paddy fields, the organics in the soil produces methane. It's a major source. And cattle, their gut produces enormous amount of methane. And so that's at least 10–15%. The other part is landfill. When you throw food, when you throw crop waste, when you throw your vegetation, they all convert to methane. Okay? Fortunately, there are fantastic solutions for all of them. For the leakage, all you need to know is you're able to detect. Then you can tighten the pipes, replace them, maintain them, the joints, etc. For coal mines, this has been tested in so many mines. It's what's called degasification pump station. Just pumps that methane from below the ground, and then you use it for fuel. Okay? Landfills, again, just simple pumps out of that. Gas wells. Agriculture, farm manure. You just throw the dung from farm animals into this anaerobic digester. It converts that into a methane, and then you use that methane as fuel. The last, agriculture, they've shown what you need is frequent aeration. Just let some oxygen and air into the water. Okay? Wastewater. This is one of the most popular things now. It's being done in many places, including where this lecture is given in San Diego, that anaerobic wastewater treatment. Recover the methane from the wastewater, otherwise it will leak out to space. So let me conclude this part saying that methane mitigation can reduce warming by 0.4 of a degree by 2050. And methane and black carbon mitigation can save annually about 2 million lives, which is lost to air pollution. It can save 50 million tons of crops, and the value added is close to $5 trillion. Okay? So there's not a single reason why we don't want to get rid of these pollutants.
Most people think that the Paris Agreement is the best climate treaty. It's not. The best climate treaty is the Montreal Protocol. It's the best overall environmental treaty and the best climate treaty. That's the story I'm going to tell in the next 25 minutes, whatever I have here. And then I'm going to move into what we've just done to phase out the fastest growing greenhouse gas, HFCs, the hydrofluorocarbons that Ram put up there. It's one of the short-lived climate pollutants. So when you're looking at the short-lived climate pollutants, I always like to remind people that Speed matters profoundly. We are in a window of maybe 15 years before the self-reinforcing feedbacks tip us into a completely different climate future. Now, 15 years is like that. And if we don't move our solutions a lot faster, I think it's axiomatic. You don't solve a fast-moving problem with slow-moving solutions. Got to speed it up. So when you look at the array of short-lived climate pollutants, and you look at the strategies you all were mentioning and that Ram mentioned, these bottom-up strategies, they're great, and it's encouraging to see this class thinking of these solutions, including in very local ways. But if you want to move fast and take a really big bite out of the short-lived climate pollutants, you want to find the governance approach that already is working on this type of a problem and that has proven itself. So you turn to, for the HFCs, the Montreal Protocol. Now, I'll go through a little bit of the history of the Montreal Protocol. You know where the stratospheric ozone layer is, and you know what ground level or tropospheric ozone is. That's the bad stuff that Ram talked about, another short-lived climate pollutant. We're talking about the good stuff that protects our health as well as our built environment and our agriculture. And we started destroying this, and we discovered this through some brilliant work by another professor who teaches here at the University of California, San Diego, Mario Molina and Sherry Rowland. 1974, they published a paper in Nature saying it looks like one of the fluorinated gases, CFCs, that were in all of our spray cans for hair spray, underarm deodorant spray. We were producing 6 billion spray cans a year propelled with CFCs back in 1974. So these guys not only published a great paper, they also catalyzed a broad scientific effort to follow up their hypothesis to see if it was empirically correct. Could we determine that the CFCs were truly destroying the stratospheric ozone layer? Could we measure that? And this is a computer simulation of the ozone hole. And you can see that, and you look at the date, this is from September 2016. We are still experiencing this, even though we've managed to stop the CFCs that we were doing back in 1975. 74 rather. Then I wanted to go back to this. Ram showed this paper, but he didn't put his name on it in his slides. Okay, so Molina and Rowland say in 1974, the CFCs are migrating to the upper atmosphere and destroying stratospheric ozone. And Ram says the next year, by the way, these are super greenhouse gases as well. They are going to be another problem. So we started, and you all are way too young to have been a part of this, with boycotts. Boycotts can be very useful. We stopped using hairspray, underarm deodorant spray, roach spray. We said this is a bad idea. California was way in the lead of this. But soon the entire country was boycotting, Canada as well, Europe as well. Then we had some national measures. Then we had some in the European Union, and then we created an international treaty, the Montreal Protocol, to protect the stratospheric ozone layer. We did two phenomenal things along the way. We saved the world from the first great threat to the global atmosphere, the CFCs destroying stratospheric ozone. If we had not done that, we would have millions more cases of skin cancer, cataracts, suppressed immune system, damage to the built environment, damage to agriculture. Where Molina and Rowland was the chairman of the chemistry department at the University of California, Irvine. Mario Molina was his postdoc. They made this their campaign to move from science to policy activism. But they paid a severe price. Industry went after them to discredit their work. They were pillared for, better part of 2 decades. And then later, of course, you'll see in this slide, they won the Nobel Prize. They shared it with Paul Crutzen, who was doing some similar work on stratospheric ozone. And it's an example that I take great inspiration from, because it's like Ram's work, a scientist who's moved from just science to policy engagement. And I don't think there's anybody better today who's done that than Ram, bringing in religion, bringing in the industry side, bringing in things that most scientists don't do. So when we created this treaty, it became the first and the only environmental treaty, in fact, the only treaty, environment or otherwise, that has universal membership. So every country in the world has joined this treaty, and every country of the world has ratified the underlying framework convention. It has ratified the protocol that puts the control measures in, and it has ratified the 4 previous amendments to the treaty to strengthen it. So it's, again, unique. No other treaty, environment or otherwise, has had universal membership, universal ratification. You'll see in this next slide what the treaty has done. So you look at the growth of the CFCs. They were the primary offending fluorinated gas at the time. And you'll see that the treaty phased out those chemicals, and you can measure the success by very precise measurements of what went up and then down, and then what substitutes came in as well. Now the challenge is some of the substitutes that are coming in here, the HFCs, have no effect on stratospheric ozone, but they're super greenhouse gases. Okay, so the treaty opened up the door when they didn't control these in the very first instance. And they phased out the CFCs, and then they moved into some HCFCs, and then some people started moving into the HFCs. And those were the ones that were the super greenhouse gases. So we created, in some ways, a problem that then we also needed to solve. So this is, again, a brief slide on the health benefits. And you also look at the cost-benefit calculation, because you can see here that this has been hugely effective and efficient, very low cost, very, very big benefits. Now you want to ask, and this is a topic that I'll teach in law school or in other graduate courses, why is this governance approach so successful? And the first thing that you'll note is the universal membership. The second thing is the principle of common but differentiated responsibility. So that means that we treat the rich northern countries differently than we treat the poor southern countries. Or one of my friends from the Philippines like to say, we treat the over-consuming countries differently than we treat the under-consuming countries. And we do that by several unique features. The first is a dedicated funding mechanism. This treaty has put now about $4 billion into the new substitutes that are better for the environment. And it does this in 3-year cycles that are called replenishments. And there's a battle between the under-consuming who want more money and those who have to put the money in, the over-consuming countries. But every 3 years, they decide on a number. It's now roughly about $500 million. That is part of the common but differentiated responsibility, and part of what makes this treaty so effective. It pays the incremental cost for moving to the solutions. Now, it does something else as well. It has technology and economic assessment panel. So this is almost real-time assessment of the alternatives. What are the better products that are coming online? What do they cost? What sectors do you use them in? How do we get them so that we can solve our problem? And these chemicals are used in about 240 different industry sectors. So you need to know quite a bit about where they go, what they're best substituted for, and you got to know what they cost as well. But this technology and economic assessment panel does this literally on a real-time basis, producing reports several times a year so that all the parties, when I say universal membership, I mean 197 parties who are members of this treaty, all of the UN members. Then we have the national ozone units. So this is a treaty that also has a unique feature. It pays every developing country, 147, to maintain a national ozone unit filled with talented people who know exactly what they need to do to implement the treaty obligations. Every year, the national ozone units receive training on what the latest substitutes are, everything they need to know to do their job. So this is, again, a unique feature. And then the treaty is one that, you know, when I started doing this latest piece of work in 2007, I went to Cairo to see the father of the Montreal Protocol, brilliant Egyptian scientist Mustafa Tolba. And I asked him at the end of a long discussion, you know, for the takeaway messages, what do I need to know to make this treaty stronger, both for its ozone protection and now for climate? And he said, I'll give you two takeaway messages. And the first one, I had to reinterpret a little bit. He said the first one was, science matters this much. And I thought, well, I'm a little wary about this, but what he meant was that science doesn't answer the policy questions, okay? Doesn't answer the economic questions. But I also took it to mean that it's a critical foundation. You have to have the good science. You have to know that you're tending to be right in your policy. The other thing he said was that the Montreal Protocol is a start and strengthen treaty. We start with what we can do based on the existing political will, and then we learn by doing, we gain greater confidence, and then we do more. So the first control measure on CFCs was to phase out 50% in 12 years. And the first time the parties met after the initial negotiations, they said, that's too easy. Let's do 75%. And then the next year they met and they said, that's too easy as well. Let's do 100% and we'll do it in 10 years instead of 12. So they increased their ambition, and they've done this for the now 30-year history of this treaty. So it's a model that is one that I think the international community needs to study and learn from, because instead of trying to get every last increment in the first negotiation, they said, we'll take this, we'll learn how to do it, and then we'll do more. So it was a pull as much as it was a push on this control measure. I mentioned the treaty has been amended 4 times and has achieved universal ratification of those amendments, and it's also been adjusted 6 times. So if a chemical is already in the treaty, this treaty has a unique feature where you can accelerate the control measure to get rid of the chemical by simply having the parties agree and not have to go back and ratify. Any party that doesn't want to do it, they have 6 months to opt out. And no party has ever done that. So every time we've done a further adjustment, the parties have all said, yes, we will go forward. So that's another graceful innovation in this treaty. So the treaty has done a huge amount of climate protection as well as saving the stratospheric ozone layer. This is the number here. So we've done more than 135 billion tons. That's a net. That's a huge number. And if you look at it in terms of gigatons per year, you know, it could have been up to 24 to 76 gigatons per year if we hadn't controlled it. So what that means is the effort to get rid of the CFCs and related fluorinated gases has solved an amount of the climate problem that otherwise would have equaled CO2 today. And you know that CO2 is about 55 to 60% of current warming. So we would have that amount again if this treaty hadn't done its job. The climate benefits were incidental. Now, Ram pointed out that these were forcers back in 1975, but the treaty didn't address the CFCs for climate purposes. It was for stratospheric ozone protection. So in a sense, we were able to solve the first great threat to the global atmosphere, the threat to stratospheric ozone, and get a free ride on climate to solve an amount that otherwise would equal CO2. So that's an incredible story that isn't as widely known as it should. But we did write a paper to try to tell this story back in 2009 as a way of moving all of the short-lived forcers into a more prominent position, including the HFCs. And this is a paper with Mario Molina, Ramanathan, myself, and a couple of other colleagues to lay down the marker on what we needed to do for fast mitigation to cut the short-lived climate pollutants and including the HFCs. We also wanted to turn the Montreal Protocol into a widely acknowledged leading treaty. This was not the case, even though it had done this heroic work. But it wasn't until the paper that I just showed you and others led by a Dutchman named Gus Velders, who calculated the initial climate benefit that I mentioned in the slide before, and then did further work on this to show the world how well the treaty had been working on the climate side as well. So we started publicizing this, because if you want to move from science to policy, you need to go through or use to your advantage media as well. So this is a slide from The Economist magazine. Now, this is a somewhat conservative British magazine, but one that is widely considered to be credible. And so if The Economist says the Montreal Protocol is a good treaty for climate, people look at that and say, this must be true. They think that even though they haven't read the underlying science, but The Economist tells them it's true, and that's good enough in many cases. Now, The Economist did another piece that I found to be just a great classic British take on climate change. They calculated everything they could think of that had begun to mitigate climate change, including China's one-child policy, the fall of the Soviet Union, and everything they looked at. This is an abbreviated version of this. All of the strategies they looked at added together would just about equal what the Montreal Protocol has done for climate. So you see the Montreal Protocol at the top. That treaty has done as much as every one of the strategies that The Economist could think of for climate mitigation. So this is, again, beginning to show that the treaty is the best environmental treaty and the best climate treaty. This is just the preview. We show the treaty is muscular and has done this brilliant job. And we're showing this for a reason. We want it to do more. And specifically, we want it now to take on the battle against the HFCs. The HFCs are the fastest growing greenhouse gas. They're super pollutants. And the treaty has inadvertently contributed to their expanded use. Thank you, Bram. So the HFCs, we make them in the factory. You don't want them, we should stop making them. We use them as refrigerants in air conditioners, in chillers, in refrigerators. We use them to blow insulating foam, and they go into the inside to be an insulating material. We use them as solvents as well. Mostly we use them for refrigeration. And they're replacing the CFCs and the HCFCs, and as I said, they have no impact on the ozone layer, but they're super greenhouse gases. This is the projected growth curve from one of the Velders papers. And you can see that it's going up to 5.5 to 8.8 gigatons per year. Now, if you know your metrics, you know this is really big, incredibly damaging if we let it go unconstrained. This is another way of looking at it. If you know your carbon budget, if we had not taken out the HFCs, if we do not take out the HFCs, they would have reduced the carbon budget by 30 to 60%. That means a heavier lift on CO2, a heavier lift on black carbon, methane, and all the other pollutants that we're talking about. What you've heard so far is the discussion about gigatons, or billions of tons of CO2 equivalent that we avoid through the Montreal Protocol. But nobody really knows what a gigaton is. No policymaker knows what a gigaton is. Policymaker doesn't know what a billion tons is. Policymaker generally doesn't know what 100 billion tons is. So how do you get their attention? We decided what we would do in the campaign to get rid of the HFCs is to turn the gigatons into temperature avoided, because people understand temperature. We are striving under the Paris Agreement to stay well under 2 degrees, aiming for 1.5, no more than that, above pre-industrial level. And then for carbon neutrality by the middle of the year, by the middle of the century. Middle of the year would be better. Middle of the century is what the goal is. So what we did through this paper, and this is one that Ram put together with Gus Velders, is to turn the gigatons into temperature, and calculated that we could bend this curve with just the HFC phase out under the Montreal Protocol by up to 0.5 degrees Celsius by the end of the century. So 0.5 degree then became both the scientific number and the political number. Everybody could say 0.5 degrees. And we did encourage everyone to. So we used the press, and I was part of the campaign for nearly a decade to attack and finally reduce the HFCs. And the press played a really, really important role. So you'll see The Economist, New York Times, Nature, the Washington Post, and so on. And we did not just the earned media, where we educated the great journalists like Justin Gillis for the New York Times, Mufson for the Washington Post, but also wrote op-eds, both ones that our team would do, including Ram, and where we would encourage others to write, to get the drumbeat out that we could go after 0.5 degree of warming. So here's one that Ram and I did back in 2012. Ram, you'll remember this, because we had to edit this to the last second, and we ended up bumping 2 senators from the op-ed page of the New York Times that day. And it repeats the story. Now, this is before we got to the 0.5 degrees of avoided warming. We're still talking about 100 gigatons. That was good. But we then had to go further. This is a story from Justin Gillis. This is a story just about how great the Montreal Protocol is. And it's, again, part of creating the history and almost a legend. This treaty was started by Ronald Reagan and Maggie Thatcher, 2 conservative political leaders. It was turned in 2007 by George Bush Jr. into an explicit climate treaty. So it has good Republican credentials as well. This is important today with the current administration. It's important because industry has learned after the initial fight with Molina and Rowland against their hypothesis to use the treaty to their own advantage. So Honeywell, as an example, and Chemours, formerly known as the DuPont Chemical Division, they know exactly when the intellectual property on their current refrigerants will expire, and they have developed better climate-friendly alternatives, and they know if they work with the treaty to phase out the old, more offending chemicals, they open up a market for the new and better products. So this is a very good use of the industry alliance. Now there are some, like my friends at Greenpeace, who will say, this is really like a conspiracy with industry. And what I say is, well, it's a fortuitous conspiracy. Industry does know how to use the treaty. And it works well that way. And without the industry support, the politics become much, much more difficult. But it does create problems for countries like India, because India does not want to pay US chemical companies for a monopolistic priced product. And that became one of the bones of contention as we tried to move the HFCs, again, these chemicals that have no threat to the ozone layer, only climate, into this treaty. So we continued with the media, and this is a piece that reflects one of the most important turning points in this campaign, when President Obama met for the very first time with President Xi of China in Sunnylands, California. They agreed to work together on two things: to constrain the risk from North Korea and to agree to phase down HFCs. This was a very good day to get these two leaders, the most important people on this issue and most others, to agree that they were going to make this a priority. Mufson from the Post writes a great story about it as well. You can go back and read this. This is an op-ed from John Kerry. So Kerry and his staff also picked up 0.5 degree. The President of the United States could say it. He put it in his speeches. Kerry put it in his speeches. This became the mantra for the world. We can go after 0.5 degrees of warming and take it out of the system. Very, very big bite. Now I'm going to whiz through this very quickly, but when you're trying to amend a treaty, as we were to phase out the HFCs, and you have 197 parties, and you're operating by consensus, you know what consensus is?
Everyone agrees. Most people agree.
Everybody agrees who matters, okay? You can always roll the really small players, okay? But it's no sustained objection from any country who really matters, okay? So that means you have a lot of work to do to build a consensus. So it took years of bilateral, multilateral, plurilateral meetings to further socialize the science, to show the alternatives were coming into the system at a reasonable price usually, and to get everybody comfortable hearing this over and over. And so a lot of the players in the world, you know, they don't do their own study. A lot of the countries, they don't have the time, but if they hear one of the leaders in their group say, HFCs are bad, 0.5 degrees of avoided warming is good, that's sufficient. They get on board. So you go through this very elaborate process, and it started with people who, Federated States of Micronesia, Ambassador Nakayama, who was concerned that his islands were going underwater and said, I need fast mitigation, what can you offer me? And we explained what he could get from the HFCs, and he said, I want to be the first country to submit a proposal to amend the Montreal Protocol to get rid of these chemicals. And for the entire campaign, the Federated States of Micronesia, a tiny country, led the effort to rally the world. They did this before the United States. The United States came in pretty soon afterwards with the North Americans, Canadians, and the Mexicans. Anyway, I'll zip through this because you see that's the Sunnyland Agreement, and you go through over and over, repeating your story, trying to keep it fresh, trying to keep it in the news, trying to get people to understand this is one of the most powerful climate strategies in the world. And over the years, we've managed to get just about everyone to say yes. We had a few holdouts. India was one. So last year, we're closing in on a deal, and India doesn't really want to do it, and they're dragging other countries back, and the Gulf states don't want to do it. Saudi Arabia, Kuwait. It's like, and they didn't really have a good reason. They just didn't want to do it, okay? So we had to change the way we did the treaty, and I'll wrap it here as we move down to the October amendment. We negotiated for an entire week. We negotiated the last day for 24 hours, and about 7 a.m. on Saturday morning, the gavel came down, and Vincent Biruta, the minister from Rwanda, the host of the meeting, said, "We have consensus." And the way he saw consensus is he looked out at a bunch of tired people and said, "I think everybody's in agreement." And he bangs down the gavel, and that is consensus. And everybody was incredibly happy at that moment. And so what we did was, well, this shows how much avoided warming, the half a degree, by a graph by Hoosvelders. Again, very, very quickly, I mentioned that the treaty treats the parties differently if they're the richer countries and the poorer countries. Well, this time we had to bifurcate even further. We had to turn the poorer countries into two groups because some were ready to go pretty quickly, but some were not. So India, Pakistan, and the Gulf states said, we need a little more time. So we said, we will change the way the treaty has worked for the last 30 years, and we will give you extra time. First time we've done that. And it was a very good move, and my prediction is that the group that is a little bit later will be swept along by the market, which is already moving very, very fast. So these are some of the press headlines. And the final comment is that the next big battle with the Montreal Protocol is to help ensure that the products that use refrigerants become super efficient, because the climate prize of a half a degree of avoided warming can be doubled if we make room air conditioners more efficient. China in the hot season in its urban areas uses 50% of its electricity for air conditioning. India, which has 10% penetration in urban areas of air conditioning, uses 50% of its electricity for air conditioning. So as that 10% grows to 50 and 100%, they blow the grid, okay? Unless they become super efficient. So this is the next big battle. And to do that, we also, as part of the negotiations, created a Fast Start Fund that would focus on energy efficiency, where countries put in an extra $27 million, and 19 foundations, including Bill Gates, Hewlett Packard, many others around the world, put in another $53 million in something that's now called the Kigali Cooling Efficiency Program. And tomorrow I will spend all day reviewing proposals to spend that money, as I'm on the advisory committee for doing that. But that's another absolutely critical piece. We can double the 0.5 degrees, and we can end up through the Montreal Protocol with an entire 1 degree Celsius of avoided warming. So it's a treaty that you should all know backwards and forwards as a reference point. If we can do this once with this brilliant treaty, we can do it for many, many other parts of climate. Thank you.